Hello everyone, welcome to this session. Our topic is formula bonding and the nomenclature. Today let's discuss about the empirical and the molecular formula. So we'll start with the concept of the empirical formula and the molecular formula. So the empirical formula, this is just the simplest formula of any compound. So the simplest formula of any compound, how it can be written is what we call the empirical formula. This empirical formula, it expresses the simplest ratio of all the atoms or the ions that make up a certain compound. Take an example, the empirical formula of a compound with the molecular, with the formula as C2H4 is CH2, simply because there we've simplified the ratio of the all the atoms that make up this compound C2H4 by simplifying by 2 in all of the compounds. In all of the compound, we get that that's the 2 from the C2 will be removed, and the 4 here, if you divide by the 2, will remain 2. So we get the CH2. This means that the simplest ratio of the CH is just 1:2. Now this ratio, it indicates the ratio in which the carbon and the hydrogen atoms combined from the compound C2H4. So that's how it is. Now the molecular formula, this is the formula which shows the actual number of the atoms present in a given compound. Take an example, the molecular formula of the above compound, that is C2H4. This means that the 2 atoms of the carbon and the 4 atoms of the hydrogen, they form the compound. Likewise, the molecular formula of water, that is H2O, meaning that the compound is made up of the 2 atoms of the hydrogen and 1 atom of oxygen. Therefore, the empirical and the molecular formula can be easily defined as follows: that the empirical formula of the compound is the simplest formula which shows its composition by mass and which shows the ratio of the number of the different atoms present in the molecule, while the molecular formula of the compound is the one which shows the actual number of each of the atom present in its molecule. I hope it's clear. Moving on. The empirical formula simply it differs from the molecular formula of the same compound, since already the molecular formula agrees with the molar mass of the compound. So that you have to note it. Now let's see the information given by the empirical and the molecular formula. Take an example. The formula for the water is H2O. Now from this information, you can see that there is 2 hydrogen atoms. They combine with 1 oxygen atom to form 1 molecule of water. Now the molecules of hydrogen atoms, they combine with 1 molecule, 1 mole. Moles of hydrogen atoms, they combine with 1 mole of oxygen atoms. Now the moles can be changed into grams using the relative atomic masses. So we can write that grams of hydrogen combined with 16 grams of oxygen. In the same way, that will be that 1 gram of hydrogen combines with 8 grams of oxygen, while the 4 grams of hydrogen combines with 32 of oxygen. The masses of each substance taking part in the reaction are always in the same ratio. Therefore, the molecular formula of a compound, you can tell simply how many moles of different atoms combine and how many grams of different elements they combine. Now, the number of each of the atoms of different elements that combine to make up a compound and the percentage of each atom in a compound based on the these lumps of each atom, and from the empirical formula you can tell the simplest ratio or the proportion of the different atoms that combine to form a compound. Now, let's see an example. The empirical formula of ethane, that is C2H4, and the propane, that is C3H6, with the molar masses 28 gram and 42 gram respectively, is CH2. This is the same although the two compounds possess different molecular formula and the masses. Now, in general, the empirical formula multiplied by a whole number n gives the molar mass of the compound. So long as the value n is known, then the molecular mass can be deduced. For example, suppose the molecular mass of ethene is 28 grams, its molecular mass can be deduced thus as follows, that the empirical formula is this one, CH2, the molar mass is 28 grams, then the CH2 in bracket N equals to 28, that is the molar mass. So this means that 12 plus 2 in bracket N equals to 28. This 12 is for the carbon, while 2 is for this hydrogen. So we get 14n is equal to 28. When you are trying to make n the subject, so you divide by 14 both sides. So n will be equal to 28, you divide by 14, that is 2. That's the molecular mass of ethene. Is just, you take this 2, you multiply to this, the empirical formula that you get is C2H4. I hope it's clear. Similarly, suppose the carbon dioxide has a molar mass of 44 grams and its empirical formula is CO2. Its molecular mass can be determined thus as follows. The empirical formula, we know that is CO2, the molar mass, that is 44 grams. Now, CO2 in bracket N equals to 44. So here you know that the 44n, that is the molar mass of this CO2. So it will be equal to 44n equals to 44. So you try to make n the subject, so you divide by 44 both sides. So you get n is equal to 1. So the molecular mass of carbon dioxide, if you take this one, you multiply to this CO2, you get the CO2. So I hope it's clear, guys. Thank you for listening. So far, we've discussed the concept of the empirical formula and the molecular formula. We've seen their difference and how you can calculate them briefly with a simple, vivid example. Thank you.